Hello, you beautiful design nerds. I'm back with yet another video. And this one is, well, I'm really excited about this one. Usually I get excited about videos that will show you a new way of how to do fancy geometry, but this is not going to be the case. It's not going to be anything fantastic in a sense of geometry. It's actually opposite to that. It's how do you create quality of life improvements to yourself by using the new tools that are available in Rhino. And I'm going to show you one thing that I found that is just blew me away, and I'm really happy to actually put this out there and show it to the world, so to say. So without any further ado, I guess I'll start talking. So Grasshopper scripts, right? Usually when you have a Grasshopper script, it's a long boy and it's only you who can operate with it. And once anyone else opens it, it's really hard for you to, or for the person to understand what the hell is going on because there's a bunch of nodes. So while I was kind of going around different tools in Rhino, I found this Grasshopper Player tool that I didn't really notice before, and I started investigating what the hell it is, and oh man, it's quite something. I believe it's a game changer. I really do. So if by default we just type in Grasshopper Player, oh, nope, not that, Grasshopper Player, and hit enter, it asks you to give it a Grasshopper file, right? And I currently don't have one. We will need to build it. But basically the way it works is it takes a Grasshopper file that was made for the Grasshopper Player, and without even opening up Grasshopper, it will run that script while asking you for inputs for that script in the command line. So I will start by showing you a very simple example, and then we'll do something a little bit more, let's say, down to earth, and a little bit more that's actually useful in an architectural design setting. Because I'm an architect and I do architectural design, so it makes sense for me to show you something that is useful for architectural design. If you're well, no, shouldn't say that. If you're a product designer, it's still a very strong and useful tool. You'll see. So let's just start by going into Grasshopper, and here under utilities, you can see that if you're running Rhino 7, by the way, very important that you run Rhino 7, you can see this context bake, get geometry, blah, blah, blah. This stuff that has the purple line underneath it, these set of nodes that are new in Rhino 7, or maybe in a new version of Grasshopper. These nodes work together with the Grasshopper Player and are made for Grasshopper Player. So the way they work is you get some geometry, right? You get some geometry in, you get some, I don't know, some numbers, get number, you get that one in, right? And then you say what happens with the geometry that you're gonna get and with the numbers that you're gonna get, right? So let's say I want to be able to populate any kind of form with a bunch of points and then create spheres on those points. I don't know. Something very simple just to get the point across, right? So if I have a surface, and let me just quickly rebuild it so that it's a little bit more complex, and just move it around, move some points around. Yeah, good enough. You have a surface, you should be able to reference it in. And for now, I'll just keep these guys somewhere here, and I'll just do it with, your regular Grasshopper nodes. So I'll just reference it in as geometry. Right click, set one geometry. Now these are linked. Then I will use populate geometry. I'll populate it with points, with some number of points, let's say 120. Bam. And then for around each point, I will create a sphere. Sphere. Bam. That's a heavy boy, isn't it? Maybe a sphere is not the best solution here. Let's do something more like a mesh sphere. Mesh sphere. Where is it located? It's just under primitives. If you don't have a mesh sphere, you can just use any kind of other node, for instance, a domain box. That would work as well. So you can either create a bunch of boxes, or you can create a bunch of mesh spheres. I'll go for mesh spheres here. With radius, that is also going to be some sort of a number. Let's say 20. I have no idea how. Yeah, 20 is way too much. Let's go for 1. 1 is too little. Let's go for 5. There we go. Right? So now we have a very simple script, right? So on every surface, we can get 120 spheres that have radius of 3, right? That's our definition. Now, if instead of just having it like so, if I say that we will get the geometry from Rhino, right? Like that. So I just delete the referenced in geometry. And for the number of points, number of points, instead of a slider, we will get a number. We can also get an integer here. Under utilities, get integer. That's like full numbers without any comma. So I guess we can get an integer here. And then for the radius, we do give it a number. Like that. And then the output of this would need to be baked back into Rhino, right? So under utilities, there's also context bake. This guy right here. Click there, connect, you're done. You have yourselves a very, very complex, very interesting script, right? It doesn't work. The reason why it doesn't work is because it's used for the Grasshopper Player. It doesn't really work right now with the surface because it's not reference 10. That's fine. We will fix it. I will talk about these nodes just a tiny bit. If you right-click on them, there's a bunch of stuff that you can change. So for instance, here, under Get Geometry, I can choose what kind of geometry is it going to be. So it's not going to be points. I untick it. It's not going to be curves. It can be surfaces, it can be B-reps, it can be sub-Ds, and it can be meshes. That's fine. Then for how many geometries the script should be waiting for, I want it to be at least 1, right? So that's fine. And at most, well, for this particular script, also 1, right? I just want to work with 1 surface at a time. So I just choose at most 1. Then here's the name, get geometry. I'll just say guide surface or guide geometry. And then for the prompt, I can click on the prompt and I can write here just give me the good stuff. Right? Same thing for the integer. For prompt, I can say how many balls do you want? Right? And at least, it needs to be at least 1 ball, and at most, I don't care. So it can be an infinite number. Sorry, this is not how many. This is not how many, this is actually how many inputs do I want. So I do want only 1 input because it's only 1 geometry. I only want 1 number to be inserted. So at least 1 and at most also 1. That is not a number. Let me change to English. And now, yes, 1 number. And then for minimum, so that number, what's the minimum range of that number and what's the maximum range? So the minimum range is at least 1 and the maximum range I don't need to define it. It can go until infinity. I should probably define it because some of you will try it with 50,000 and it's gonna crash your computers. But you know, it's on you. It's on you. You should know better. Same thing for the get number. Oh yeah, and I can here, instead of get integer, I can just call it amount of balls. And then here, size of balls, right? With the prompt is how big are your balls, right? With giving it also at least one number, at most one number. Minimum should be 0, or let's go for 0.001, something very, very small. And for maximum, we don't define maximum. We can say that you can have as big of a ball or big balls as you want. And that's it. That's it. Now we have ourselves a setup that should work, right? So I will just save this Grasshopper definition, save document. I'll just save it to desktop, balls, hit save. We're ready to go. Okay, and now back to this bad boy here. Now the Grasshopper is not running, right? So I will just type in Grasshopper Player, hit enter, and it's gonna ask me for the where the definition is. I'll select the balls, hit open, and now you can see that it's here asking me for the questions that I wrote down. Give me the good stuff. Here's the good stuff. How many balls do you want? I want to have like 200 of them. How big are your balls? Let's go for, they are 5 units big. Voila. It just makes a bunch of balls, right? So see how powerful this is? Because right now you can have a bunch of scripts that do simple stuff like this. Well, not like this, but you get it. You know, simple stuff. And you can just have a library of that. And instead of doing all of the repetitive tasks over and over and needing to fish out where the hell your definition is and reference stuff in, you can just use the Grasshopper Player and do it this way. This saves so much time. So now enough about the balls. Let's do something a little bit more architectural. I'm going to actually, by the way, everything that I do in millimeters. So if you want to follow along, just do it in millimeters. I'm going to create a box that is, let's say 10,000 millimeters. That is not 10,000, that was 1,000. I'll do it again, 10,000 by, let's say 4,000 by 3,000. Right? A big box here. And I'm going to move it up and rotate it, or come on, rotate it. And yeah, I guess this works. I'll just Boolean union these two boxes together. So we have ourselves some sort of a form. And this is an architectural study, right, of just volume. Just think about it this way. Usually when you showed something like this to a client, the client will not really understand the scale of things and so on. So what I really like doing is I like adding windows and doors and stuff like that to the volume to make it a little bit more, let's say, user-friendly, right? A little bit more friendly to people who are not used to these three-dimensional, you know, very simplistic shapes. So I'll just hit it with a shell command, and I'll give it thickness of 300 millimeters. I'll say that this is open, this is open, this is open, this is open, hit enter. Now we have ourselves a thickness for this. Already starts looking a little bit more architectural, right? And then I'll just cut out a few holes for where I would want the windows to be. And I'll be very, let's say, pragmatic about it. I'm not going to think about too much about the composition or stuff like that. Just a bunch of holes here and there, right? And all of these holes have different proportions and different heights and so on. And maybe let's add one more in here. Actually, I should probably do it properly with a 3-point box like that. Push it in somewhere here. Yeah, sounds about right. Scale 1D. Just make it wider. Push it up. Yeah, there's just going to be one window here. I don't care. Okay, and then we do, the old trusted Boolean difference for the building with the boxes that we've made, the negative boxes. Then we get rid of the boxes because I forgot to tick mark one thing, and we have ourselves, a carcass. Carcass? No, that is not an English. It is an English word, but it doesn't mean what I want it to mean. We have ourselves like an unfinished building. Let's say it like that. Just a structure. Now to add the windows here, what I would usually do is just, create a 3-point rectangle, take it, scale 1D, scale it to be from here to here, let's say a meter. Click there, copy. You don't need to follow along. I'm going to be deleting this, by the way. At least this, at least this portion. Then scale it to fill in this whole thing. Offset, offset it inwards by whatever amount you want. I'll just use 3 centimeters. Let's lock the, oops, that was the delete button. Let's lock the building altogether. Offset that inwards, like that. Create planar surfaces for this. Create planar surfaces, sorry for the frames. Create planar surfaces for the windows themselves. Or for the glass of the windows. Take the glass parts, offset surface them inwards by 0.0, that we're in millimeters, so by 20, by 2 centimeters. And this bad boy gets inserted inwards or offsetted inwards, offset surface. The frames get offsetted by, let's say, 100 millimeters, right? So that means the windows will need to move in by some amount, don't really care. And we have ourselves, windows. Hurrah. The problem with this is that I would go around the whole perimeter, and for every, window opening, I would create these kind of very simplistic windows, and then the client changes his mind. Or we just have a discussion with the client and I need to make a version 2.0, or then version 3.0, version 3.1. And everything's constantly changing, and the proportions of the windows are constantly changing, and they're rotating. And this, I'm just wasting so much time doing this that it's just bad, right? So instead, we are going to do a script. Not this kind of script. A new document. A script for the windows. And I'll show you how I kind of treat it. First of all, I need to decide what kind of input I'm going to have. And that is just going to be, I want to just give it a rectangle, a bunch of rectangles. For every opening, I want to create a rectangle. That's it, right? So I'm going to give it a bunch of rectangles, and let's say that this rectangle right here, bam, bam, 3-point rectangle, and this rectangle right here, bam, oh, come on, 3 points, please, like that. And one more, let's just use this one, why not? 3 points from here to here to here. These 3 rectangles are going to be my test subjects, right, for creating this script. So I'm going to reference them in, set multiple curves, and I'm going to, first of all, divide them up into proper sizes, because, for instance, a facade like this would be very, very expensive to do in, or window opening like this would be very expensive to do with a single glass. Usually you want to have vertical divisions, right? So I will want to divide this up. And the way I do it, it's like a million different ways of how you can do it. The way I'm going to do it is I will say that I'm only interested in the top line and the bottom line of this rectangle. I don't care about the vertical lines. I only care about the horizontal lines, right? I'm going to extract those, and then I'm going to divide those lines into segments that are as close to, let's say, 1 meter in width as possible, or some sort of variable. So how do I do that? It's a little bit, it's not going to be pretty, but let's say if I explode these curves. Oh, and I probably should do the bifocals. There you go. Now you'll see the names of it. If I explode these curves, now I get 4 curves for each of the rectangles, right? Duh. And then for each of these, I can say, what's their direction? Are they horizontal or are they vertical, right? So I'm just going to ask, how do we do this? Let's do evaluate curve. So we'll do evaluate curve, add some sort of parameter, and the parameter doesn't matter. These are straight lines, right? So the parameter, like the direction of them doesn't change. So I'll just go for 0.5, the middle point. And I should probably just do it this way, 0.5. Just in the panel. Slider works as well, but panel is smaller. I like panels in that way for that reason. So we get ourselves tangents. Tangents are directions, right? So if I take these tangents and I deconstruct them, struct vector, if I deconstruct these tangents, I get their x, y, and z coordinates, right? And if I were to check those z coordinates, you can see that z is, if it goes up, it's +1. If it goes to the side, if the line is completely horizontal, it's 0. And if it goes down, it's -1. We only care about the ones that are 0, right? So I'm going to take those tangents and I'll ask, or the z component of those tangent vectors, and I'm going to ask, yo, are you very close to 0? So I'm just, because sometimes you kind of mess up the 3D modeling and you don't want to deal with the tolerances. So I'm just going to ask, yo, are you larger than 0.001? Some number. Again, instead of a slider, I'm just going to use this, a panel, like that. And it's going to give me a bunch of yes and no answers. And with those yes and no answers, I can cull pattern. I can remove the segments. That's the list that I'm culling, the segments that are actually larger than 0.01, right? Pattern. What? Oh, smaller than. My bad. I'm sorry. Don't yell at me. Smaller than, right? So you can see that it's weird because only this segment got removed and this segment got removed and this segment got removed. The reason for that is because this vertical segment is -1, meaning that it's indeed smaller than 0.001, right? So that's a problem. How do we fix it? Well, quite simply, actually. We can ask it, are you also smaller than negative 0.001, right? Because in doing so, we're basically saying that the range that we want is in between -0.001 and 0.001. I know that you're thinking you could just ask, are you equal to 0? But again, I don't want to deal with the tolerances. So now, with this done, I need to somehow join these up together. And a really nice little tool that does that is called OR. Gate OR. So either this is true or this is true. If either one of these are true, then this is going to say true. And this is going to cull. And it doesn't work. Hello? Why? Or should it be and? Wait, let me double check. Should have prepared true, true, true. Yes, yes, yes. Yes, indeed, indeed, indeed. It needs to be and. It's not or, it's and, right? Isn't it? No, it's not. God damn it. I'm making a fool of myself. Wait. Okay, let's do it the other way around. Jesus Christ, this is falling apart quite early on. Let's do larger than. Okay, let's do it other way around. Larger than 0.01. And then if I just connect it this way, oops, sorry. If I connect it this way, then it gives me only that, but I can right click on the P input here and choose invert. Right click on the P, choose invert, and then we're back to normal. And then I think if we do, and let's see. So this gives me true, false, false, false. Yes, that's good. And then this one needs to be smaller than, like that, and like that. So I accidentally deleted the other one. The other one you shouldn't delete. The second smaller than you should keep, like that. And this one gives me true here. So now if I say or, gate or, between these two, and I check, then I have two true statements. Yes, that is good. Whew, okay, saved. Instead of smaller than for this one, you just use larger than. Okay, we're back. We're back to where we were. Up until here, there are no variables that we mess around with. It's all static, right? So we have ourselves the two curves for each branch, right? Then I will use divide curve component, divide curve. And it's going to ask me, yo, how many divisions do you want? And I don't know how many, right? Because I don't know the lengths of them. And for now, by default, it says 10 for every one of them. I don't know. No, we're not doing that. So instead, I'm going to say, yo, what's the length? What's the length of the curves? And if I were to take that length and I were to divide it by a desired length, you know, of these curves, I would get an approximate number of segments that we should have to actually that we should have to add to make up the full curve. God damn it. My mind is just going places, and I really want to do justice to this tool. Bear with me. I'll get the ball rolling real fast. Okay. So we have lengths, right? And if I just show it to you, 2.3 meters, right? Right here. So if I take those 2.3 meters and I divide them up by 1,100 millimeters, 1.1 meter, right? Here, I'm going to have 2.15 segments, right? This is how many segments of 1.1 meter we need to kind of fill in the void here, right? With the panels. With panels that would be 1.1 meter long. So then I can say, well, this guy wants us to give it a full number, and here we will almost never have a full number. So I'm just going to say, give me an integer. Change this to an integer, right? Like that, and now if I check, it's 2 segments. Okay, cool. I connect it this way, and now we have 1, 2, 3, 1, 2, 1, 2, 3. So I kind of know that this is the first curve, right? Or the first rectangle, and these two are the second and the third one, just by looking at the data tree here. So we have successfully divided the curves, and we have successfully created what do you call them? Parameters on the curves. We know where the points are located in terms of the position on the curve, right? So by using those parameters, we can then shatter these curves into parts. Shatter. We shatter the curves with the parameters. And visually, nothing really changes, right? Visually, nothing really changes. But if I were to check it here, how do I show it to you properly? Instead of one curve here now, we have 3, right? Instead of one curve here, we have 3. Here we have 2 curves. Here we have 2 curves. Which means that now I can actually try to take the curve from here and the curve from here and try to loft them. It's not going to be easy because they are in their own data branches. And the data tree, by the way, looks just something like, oh my God, where is it? No, not Graph Mapper. Param Viewer, there we go. Just something like this, right? Pretty hard to understand what the hell is going on, but the principle of it is pretty straightforward, or at least it should be pretty straightforward. I wonder why is it 5 there, or 6? 1, 2, 3, 4, 5, 6. And here we have, sorry, just bear with me for a second. Here we have 2. Okay, that's fine. That's fine. So what we want to do is we want to, first of all, simplify this bad boy. Right-click, simplify, the call pattern. And here we have 3 rectangles, like 3 data branches with 2 curves in each branch, right? Which means that we need to mess around with the data tree here. And this is not going to be a tutorial about the data trees. If you want that is on my channel. You can find it. If you just type in data trees, Grasshopper. But here, we are going to do it the old-fashioned way of how tutorials work. It's repeat after me style of a tutorial. I'll go to the tree and I'll choose the very, very naughty tool called Path Mapper. This one. And if I just connect my shatter curves into the Path Mapper, right-click on it, and I'll just choose, I don't know, create reverse mapping, something like that. Doesn't matter. Here, it's going to tell me what it's going to do with the data tree. Okay, now time to just broadly explain it. Our data tree right now is 0, 0, and then index 0, 1, then 0, 1, indexes 0, 1. So this is 0, 0, and then index, right? So this is like the data branch address, and this is the number of the curve in that branch. And what do we want to do with those? How do we want to reshuffle the structure? And the way we want to reshuffle the structure is actually going to be, this is going to be so weird. Instead of A, B, and index, we're going to say A, then we put index in as the address, and then for the, oh my God, for the indices, we are going to use the second portion of the branch. This should work. This is why I'm saying repeat after me, because god damn it, even explaining this is not easy. just do it this way. A, B, index A, index B, right? Now, if I look at the data branch or data structure, I can see that it's always going to be pairs of curves, right? And those pairs of curves are always going to be this one and this one, this one and this one, this one and this one, and then so on, going through every single window here, which means I can loft between them. God damn it. Okay. So I forgot one thing, and that thing is this curve right here goes, let's say, from left to right, and this curve right here, since this is a rectangle, it goes from right to left, meaning that every other curve needs to be flipped. We go way back to this explode node. No, not to this explode node, sorry. We go back to here, to cull pattern node. And we will need to do a little bit of tweaking for this, right? Cull pattern, remember, gave us these two curves. These are not shattered curves. These are just full one line, second line. The second line needs to be flipped. How do we do that? We use list item. We will always have two lines, right? So we use list item and zoom into it and click on the plus sign to get +1. This is the first item on the list. This is the second item on the list, right? The second item on the list gets flipped, flip curve, gets flipped, and then they get merged back into being normal, right? So merge, or not into being normal, but merge back into one data tree or list, right? Like that. That's it. Now we need to reconnect everything. Cool little trick that was taught to me is that if you do Control-Shift, you can disconnect and reconnect all of the wires all at once. The problem was that we had the wire connected like so now it's reconnecting it to itself, so we just kind of overwrite it this way. And now this should work, but it doesn't. It's a problem, one problem after the other, isn't it? Isn't it? Okay, we have ourselves curves, and we are dividing them, and for some reason, it's dividing them in a very, very naughty way. Do these need to be reparameterized? Yes, they do. Okay, so more explanation. Panel, connect. This should actually work without us reparameterizing it. I have no idea why it doesn't. Let's see. How many lofts? One loft. Okay, so it doesn't actually, or does it work? 6. No, it doesn't work. Yikes. So here we get stuff that doesn't really seem to work, and that's because these are negative. Yeah, there we go. These are like negative values. How? Why? Why are these negative values? I have no idea. What if we just say cull pattern goes in here and we measure the length from here? Still doesn't work. Do I really need to stop the video to investigate? I'm gonna stop the video to investigate. I am sorry. I did not figure it out. Well, it's the problem is with the negative values here that we get because we flipped the curves. Whoopsie. Anyway, instead of shatter, we can use something else that might even be a little bit more user-friendly, let's say. So I will not use shatter, but instead I will use Polyline. Polyline because divide curve, it gives us these points, right? So I can just use polyline, construct a polyline through these curves, and I can explode the polyline into curve segments. That's the same thing as shatter, literally, right? And connect it this way. And now it doesn't work again. Please, just give me a break with this one. Why is it that every tutorial that I really want to do, I struggle with? All right, that's because you can see the addresses here. It's a 000, 010, 100, 110, and so on, right? The addresses of the data branches is crap. That extra 0 is unnecessary, so we need to remove it, because here it's basically the address that it's waiting for is ABC and then index, not AB. So to remove that 0, we just right click on the S output of the explode and choose to simplify. And now it finally works. Oh my god, that was way too long. That took way too long. Okay, now it works. Now we have ourselves a loft right here. Okay, that loft, we don't really need it as a surface. We just care about its edges. Brep edges. And at this point, like all of these separate lofts, you can see the seam here, right? All of these separate lofts, we don't really care about where they are positioned in the world, right? Or rather, what kind of frame, the overall frame they belong to. So I'm just going to right click and choose to flatten to get rid of the data tree, because data trees are not fun. Okay, lofts flattened. We get brep edges, we get ourselves all of the naked edges, and we join them up into, into curves. And now we're back to everything being grafted again, like everything being in a separate data branch. No, we don't do that here. We right click and choose to flatten again. Everything's in a single list. We have ourselves 8 rectangles. All this to create 8 rectangles. But now, as I move this slider, it adapts. Oh no. Okay, the slider edit minimum needs to be at least like 500 or no, 200 millimeters. Or else we're just gonna be asking for trouble, right? So now it's adaptive, right? Let's go back to 1.1 meter or close to it. So now these curves, very simple procedure. Offset curve. Come on. Offset these curves. Or wait, do we? Did I jumped the gun with flattening? Sorry, we don't flatten the join curves. We do want to keep them in separate branches, right? So we right click on the join curves, see output, and we don't choose flatten. Instead, we choose to simplify. It's basically we just put every single rectangle in its own separate branch so that we can do offsets for them individually and loft them cleanly, in a clean way. So offset curve, now we need to say how much of an offset distance we want to give it. So I'm just going to say 30 millimeters, connected to the distance. And you can see that it gets offset outwards. And in most cases, it will get offsetted outwards. Not always though, not always. This is a problem that we need to solve. Sometimes it's going to, actually, can I force it? Flip? No, I can't. Okay, sometimes it's going to, the offset is going to go inwards, not outwards. And sometimes it's going to go outwards, not inwards. And I don't know why, but it just does it. So for that, we need to actually do a little bit of magic with this. I'm going to say 30 here, but also I'm going to give it a negative 30. Holding down the shift key, connect the second distance here. So we're offsetting it to both sides by 30 millimeters. And then I'm going to say, okay, what's the length? what's the length of the two rectangles for each rectangle, the two rectangles that we get, what are the lengths of them, right? And it's going to give me, you know, this is for the first rectangle, the two lengths, this is for the second rectangle, the two lengths, and so on, right? You can see that these are separated right now. I don't want them to be separated. So I'm going to kind of bring back or squish back the data tree by the outermost branches. I will try to bring them back to one list, right? So these two will be in one list, these two will be in one list, you know, so that they can be compared to each other. That is going to be done by using trim tree command. Trim tree, like that. And I'll just show you. Might as well. Dash, panel. Now they are both here. And I can then sort list. I can sort them so that the smallest one is always at the top. And together with them, I can sort the offsetted curves. Oh. Let's switch around the trim tree with the length in terms of connectivity. So first we trim the tree, then we measure the length like that. And then we sort, together with the lengths, we sort the curves that the lengths belong to. And thus we will, this polyline curve will always be like the first polyline curve in the tree, in every list, is going to be the smallest one, the shortest one, right? So I can do then list item to get it. And now with it, I will always get the inner offset, right? So this portion right here, or rather, I would say this portion together with the negative part, this portion right here is just making sure that we are always offsetting inwards. You know, just so that it's never a problem, never a mistake. All right, now we have ourselves curves here. We have ourselves the outer curves here. Let's move it down and actually let me create a curve component. Curve, connect it, drag it out. Just so that they're here, you know, together, big happy family. And now we can do merge, bam, bam, merge them together like that. And we can do boundary surface for them. If I zoom in, voila, we have ourselves a surface between these. And then let's just do the same thing for the just for the glass boundary surface here, right? For the list item. Okay. Whew, we're getting there. So now we have surface for the frame and surface for the glass. Surface for the frame is pretty simple. I will just say extrude this bad boy. Let's extrude this bad boy along its own perpendicular vector. So I can just ask, are you flat? Are you planar? Is planar. Are you as a surface planar? And it's going to give me a plane, right? And I can use that plane to give it a strength. So if it's giving me a plane and I want to use a plane as direction, it's going to use the z vector of the plane as direction. That's why I can just easily connect plane to amplitude vector input this way. And I'll just give it an amplitude of 100 millimeters. Like that, and connect it to V, and it's just going to be, whoop, just gets extruded by 100. I don't want it to be kind of sticking out like that. I want it to be centered around the guide curve. So I'm going to actually move it backwards by half of this vector, right? So I'm just going to take this vector and I'm going to divide it, division, right? I'm going to divide it by -2, by -2. So it's immediately going to say, okay, sure, you want to go backwards, but with half the strength of the initial vector, right? If I hide it, now it's always centered. Let me move this out, actually. Now it's centered. Yay! Now for the glass. Glass is pretty much the same thing. We extrude. Let's just do it again. Extrude glass, and we use unit, not unit Z, goddammit. We ask, is the glass planar? This, by the way, will only work on flat, boring windows. But that's all we need, right? We use amplitude, and we say 20 millimeters. And same thing, we move it. And I will just borrow this one. Thank you very much. We move it by half backwards so that it's, nicely centered. Now we have ourselves the geometry of the glass and the geometry of the frames, all ready to go. What's next? Next up, we will just, I guess, color it nicely and then call it a day. So to color it, or I wonder if color will transfer. Color will not transfer, so we don't care, right? We don't care. This is done. This is our script. This is our definition. Let me move it back in, right? So now we need to actually make it into the thing that I'm doing the tutorial about, right? Into a Grasshopper Player enabled script. So I'll go back to params, utilities, and I'll start seeing what kind of inputs I'll need for this to work. So of course I need the curve. So I'm going to go and get some geometry in here, connect it like that, and then right click and untick everything except for curves, like that, and then call it curves or rectangles. Yeah, rectangles. And prompt, give me vertical flat rectangles. There we go. Then here everything is kind of static, so we don't care, we don't care, we don't care, we don't care. Oh, I forgot one thing. How many? At least one, at most? We don't care, so we don't plug anything in there. Then here we don't care. Division, there we go. This one we care about. Utilities, get number. Plug that bad boy in. Instead of just a boring number, we use this one. Right click, call it desired window width. Like that. At least one number, at most one number. We will try to use the same number for all of the windows in the building, right? If you want to use two different numbers, just run script 2 times on 2 different sets of curves, right? Minimum amount should be, well, our windows should be at least 100 millimeters wide, I think, right? Like anything smaller than 10 centimeters should not be considered a window. And then maximum 5 meters. 5 meters. There we go. Then here nothing happens. And here we have ourselves the also get number. Bam, bam. Oh, messed it up. There we go. And here I'm gonna say desired, or not even desired, but this is a constant, so it's gonna be window frame or just frame thickness. Prompt: how thick is ya boy? How thick is ya boy? At least one number, at most one number. Minimum, you know, I would say window frame should be at least 1 centimeter thick, and maximum, they shouldn't be more than 50 centimeters thick, right? So that, and the last one, or rather two last ones, is a number here, get number, and a number here, get number. And keep in mind that here I'm always doing everything in millimeters, so I'm writing my numbers in millimeters as if they were to be written in millimeters. But for you, you might, you know, if you're used to meters, then your numbers are going to be different, you know, especially minimum and maximum ranges. But here, this is the depth, the frame depth. And this is glass thickness. And for frame depth, the prompt is going to be how deep do your frames go? Sure. And the prompt for the glass is going to be how bullet proof is your glass, right? Minimum for the frames is at least 5 centimeters, I would say. Maximum is, you know, it can go for a meter, sure. Minimum for the glass is 5 millimeters. And maximum for glass is, it can be a meter, sure. You know, in moon or something like that. And then by the end of it, we merge everything into big one happy family, flatten everything, right? So everything is flattened out, and we do get, or rather context bake. Is there anything that we can, no changes here can be made. That's fine. Okay, time to save this bad boy. Save document. Windows. With a Z, of course. Save. Close. Grasshopper Player. That is not Grasshopper Player. Grasshopper. Come on. Okay, let's use the... Can I actually get the Grasshopper Player to pop up here? How do you do that? Show toolbar, Grasshopper Player, come on, give it to me. Give it to me. Give it to me. Come on, where are you? Animation preview, you're not the one that I'm looking for. Player, P? Is it P? It's not P. Is it P? Properties, plain, stupid. Okay, what if I just write player? Yeah, okay, player, then it gives you Grasshopper Player as the first option. Sure, Grasshopper Player, scroll, Windows, open, give me vertical flat rectangles. Here you go, this one, and this one. Enter. How thick is ya boy? So how thick are the frames? I don't know, like 30 thick. Desired window width. Oh crap, how thick is ya boy is... messed up. I messed up immediately. Grasshopper Player again. How thick is ya boy is how wide the windows are. There. Enter. How thick is your boy? A meter thick. How thick? Wait. Number must be smaller than or equal to 500. This is weird. That means, let's go back here. Let's investigate. This is actually important. It goes through. Where's the desired window width prompt? Frame thickness. It doesn't. How thick is your boy? Is the frame thickness, and desired window width prompt is how wide is your window. Let's just do it this way. I wanna check one thing. Let's bring everything in here to the start, and let's see if it's going to follow. If it's going to follow this logic of reading it from top to bottom according to how the nodes are placed, right? So I'm going to File, Save the document. So it first should ask me for the rectangles, then for the thickness, how thick is your boy, then for the window width, and then for the frame depth. Let's see. Player. Windows open. Okay, give me flat rectangles. There. Okay, that's fine. How thick is your boy? 50. How wide is your window? Okay, so then it's asking me for the window width, which is a meter. How deep do frames go? 100 millimeters. How bulletproof is your glass? 20 millimeters. Voila, we have ourselves some windows in here. Yeah. And you can see that the windows are placed in a weird way. That's because my curves are not centered in the middle of the openings, but it does work. Okay, more experimentation. Now if I do that, and that, save. So I reshuffled it. Player. Windows. Okay, rectangles comes first as per usual. Enter. How wide is your window? Okay, so this is actually, I hope it's gonna be useful for you because it matters where you position your nodes, right? It's going to 1,000. How deep do frames go? Frame depth. So it's going to read from top to bottom according to actual position of the nodes in your file. Very important to know. Okay, let's just finish up here. I'm going to make more windows or more rectangles like that. 3-point. That. Actually, let's do this. Unlock. This is going to be faster. User. Is there a rectangle here? Okay. Cell curves. I still need 2 here. I need 1 there. Okay. There. Dupe border. Unselect. Delete. Cell curves. Select curves. That has curves in. That has. Okay, we have curves everywhere. Let's just actually curves. Let's just do this. Will be easier. Okay. Cell CRV. Move them in here. Okay. Now take the curve from here, for instance. Oh, actually, now we can lock it. All of our curves go in by 200 mil into the building. Like that. Minus 200. So I'm gonna be fast about it. That is done. And now for this, I will just change the gumball to be aligned with the object. 200. You, sir, go in by 200. And you, nope, not you, you go in by 200. Okay, so we have this now. And let's YOLO it. Player. Grasshopper Player. Windows, open. Give me flat rectangles, all of them. Enter. How wide is your window? 1,000. How deep do frames go? 100. How bulletproof is the glass? 20. How thick are the frames? Or how thick is ya boy? 30. Voila. We have ourselves a script that will generate windows for us every time from rectangle curves. We are saving time, a bunch of time. I hope you're as excited for this as I am. So from now on, the Grasshopper definitions, if it's like this Grasshopper definition is going to be available for Patreon supporters, for my Patreon supporters, link in the video description below. Just like any other definition that I do on this channel. The scripts that I will find useful, that I find useful for myself as I work, I will be giving away for free for the Patreons of any, within any range of how much you support you give. I just want to give back something. So that's going to be a thing. And actually, I really hope to see some cool stuff from you guys. So if you have come up with anything in Grasshopper, and you can just kind of make it into a Grasshopper Player-esque definition, share it with the community. Just send it over, and I'll show everyone, right? And I'll show where to get it as well. So that is about it. Really good tool that I'm really going to use a lot, and I will keep giving cool stuff to my colleagues and the Patreon supporters as well. Okay, enough of me blabbing. I'll see you in the next one. Later.